Hello. This COVID data lecture is for those of you who have been keeping up with this playlist because we are going to build upon the COVID time series. So, what I want you to do is go to collab.research.google.com and click on the better COVID time series. That was what we made in the last lecture in this playlist, and go ahead and open that up. And what we're going to do is we're going to copy this. If you don't have it for any reason, you can copy mine. And go to File, Save a Copy in Drive. Okay, do that now. And then I want you to label it Even Better COVID Time Series. Okay, what are we going to do? So I want to answer a question. And the question that I want to answer is the following. I simply want to know, how are we doing with COVID right now? Okay, so to start to answer that question, let's take a look at what we actually do have. So when you copy in your notebook, it has not been run. Okay, you need to run it. So we're not going to run the whole thing. Now to run each individual cell, you can click on it, press Command Shift, Shift Return, and that will run it and reload the data based on today. Now, I am recording this in December 2021, very beginning. Today's December 2nd, when the new Omicron variety is causing some concern. Now, I'm going to go ahead and get rid of some of these extraneous columns, which we don't need to know again, like df shape. And so to do that, you can always hit the delete cell. I'm going to continue to focus on California. You may focus on your own state. Okay, so press Shift Enter to run that. And again, I'm not worried about the shape right now, so I'll delete that. This admin 2, what it does is it renames basically the counties as the indices, so that's good. Press Shift Enter to run that. Selecting only dates as the columns, this gets rid of the extra stuff, so go ahead and run that one. And if you scroll down to the end of this, let's just check it out. Okay, so here are the total number of cases, right? And we can see it's a lot and it's been a lot. And a natural question to pose is, yeah, but how many new cases is there? And it's clear that if you take the you subtract basically, right? If I look at 1130, I subtract 1129, that will give me the number of new cases that were reported on 1130. Okay, now note that in 12.1, it looks like some of these have not been recorded, so that could present its own little issue. But that operation will work, and I like that because instead of like looking at the whole curve and saying, oh, is the curve flat, it gives me an actual number that I can look at. So what we're going to do next is something new. So I'm going to do a new code cell. Before I do that, I want to check the name of the data frame, and it's df Cali. And what we're going to do is we're basically going to transform columns, okay, to difference between columns. All right. And there is something that you can do to do that. I'm just going to, so maybe I'll rename it. Sometimes the question is like, do I call it the same thing or do I rename it? When you're doing something new, it can be worth renaming it because in case it messes up later, then you can go back to df Cali. Okay. So this is I called it df diff because, okay, so what am I doing here? It's a difference matrix, and then so I take the original matrix, I have df Cali, there's this dot diff operation, and if I set axis equals 1, which is the columns, then it's going to just take the difference of the numbers of every column. And to see what we end up with, we can then again look at the first 5 rows. Okay, so go ahead and try that. See what you get. Press Shift Enter. And if we scroll to end, I think that's more what we want to look at. Okay, see, this is it's indicative of a lot. Okay, first of all, we see that it did in fact work. So we could see that there were 60 new cases. on 1130, 54 and 1129. But this is interesting, right? There are 464 and 1128. Now, you don't need to be a data analyst to figure out that this was actually Thanksgiving weekend in the States and nothing was reported. Okay, so this 464, it doesn't really give you the indication of how many, cases there were that day. Okay, and then if we scroll further back, you can see it looks like the weekends also do not have reports, which makes Monday higher than it should be. So based on this alone, I would say that this is not the best way to look at it. Okay, it's close, but I want to do something different. And what I want to do is actually look at, instead of just say today or yesterday how many new cases were reported, what if we look at it in a smaller time frame? Like, I like 7 days, because if you do the last 7 days and that takes into account any kind of like weekday reporting issues, like if, I don't know, do more people do this in the middle of the week? I'm not sure. But if we only count every 7 days, that should actually work, right? Because now the idea here would be that you sum the previous 7 days, and that's going to exclude kind of holiday issues and things like that. Okay, so what is the code to do that? Well, before I do that, actually, if you look at this, see these NANs, right? That's a problem. It stands for not a number, it's a null value, and we want to get rid of that. That can mess up things down the road. Okay, it doesn't have any value, right? When we look at 123, we want to know how many new cases there were since 122. Sure, you could count 122, but at that time, I don't know, we're not focused on the very beginning of COVID. Like, were there cases reported in 122 in California? Maybe somewhere. We're more focused on like how it's been growing over time. So, we can safely, I think, get rid of that. I mean, it's nothing right here. The idea of changing it would be that you could go back to the original and possibly keep it as it is, but it's going to be easier now just to get rid of it. Okay, so do a new code cell. Do that by clicking plus code. Do that now. And then, so we'll just say delete first column. And so we're on df diff equals df diff. We can just there are different ways you can do it. Let's just do an iloc. So let's select all rows, okay? So index location means we're selecting by the number. All data stored is in a data frame, which we have here, is rows and columns. And so just to give you an indicator here, like if I want to look at right here, where is that stored? Well, this is the second row and the fourth column. That would have an index of the 0th first row, 0th first, second, third column. Okay, so that right there, comma, selects all rows. And to select the columns, you start at the first column, meaning not 120, 221, not the 0th, and then you put the colon again to select everything after it. And it's always nice to check it, right? After you make the change to see, did it do what's expected? Because if you make a mistake, and I do make mistakes, everybody does, then you'll be able to detect it most likely. Okay, so press Shift Enter, and you can see that the null value column now has been deleted. Okay, so back to this question of now can we just compute every 7 days? So, okay, you guys, we're getting into stuff that's a little nitty gritty with coding, and I did look it up so that I could do it. It's not something I know off the top of my head. I found something that's kind of interesting. Wait a minute. Yeah, I think I want to do one more thing before this. I did it by rows and not by columns. So what we're going to do first is we're going to transpose this. So basically I found a solution that said how to do it by rows, but we have it set up by columns. And you could do it by columns, but it's also easy to switch them. And we do in fact switch them if you remember when we graphed them. So if I go to a new coding, actually I think it's right here. Yeah, it's in the next one. It's taking the transpose. Now the only difference is that we're calling it something different. So let's just call what we have it df_diff. So it's the difference data frame. It is for California here. And df_diff.transpose. And so it should look similar to what's underneath, right? If you want to look at what's underneath, you can see it there. And, it's the only difference is the entries are going to be the differences, not the total number of cases per day. They are actually going to be the total number of cases per day instead of the cumulative sum, which is what they were. Okay, so transpose just flips the columns and the rows. That's what you call it. It's basically you just rotate it. Okay. All right, so we run that, and you can see it flips. Okay, so now before doing any graphing, we are going to go ahead and use this row solution that I have for you. And so here it goes. You got to reassign it. Okay, so we're going to call df_diff now something different. And basically, well, let me just put it in here. So it's df_diff, okay? Right, so basically we're reassigning it. So the operation is now dot, there's something called rolling. Now, my solution is probably not the most elegant, okay? I'm sure there's a more elegant way, but it works. And we said the minimum periods equal to 1. And the key is that the window is going to be 7, okay? So what that's going to do is we have to pick the operation. So the operation we want is dot sum, okay? So what this is going to do, it's going to sum basically every 7 like rows, okay? And that's what it's going to give you. It's going to give you the sum of the 7 rows. And to show that, here's what I want to do. Okay, I haven't run it yet. Instead of looking at the head, okay, do a new code, so I'm looking at the tail. Okay, so df_diff.tail, and it just shows you like the bottom, entries, right? We saw this before as columns, now we're seeing them as rows. And so the idea here is that instead of producing this number 0 for 12.1, it's going to produce the last 7. Okay, I think the last 7. Let's check. All right, so it's going to actually do it for every row. Okay, so df_diff.tail. Okay, double check that code. It's new code. It's important code. And again, it's just whatever your data frame is called. You have a dot rolling, meaning that it's doing it through the whole data frame. It's just going to sum every 7. Okay. All right, so let's try to run it. See what we get. And that looks good. Why does it look good? Because, well, first of all, it's a sum, right? It's a larger number. And you can see that, note that there should be no change between 1130 and 1121 because there are no new cases added. And in fact, there is no change. Okay. All right. I'm pausing on this just because I'm like, well, is it 5? Wouldn't it be like you add? Well, see, you're not adding straight 60 here because the issue is you're subtracting off what the previous ones were. Let me show you. If you ever want to dig for more, what you can do here is you can take like the last 10 rows. Okay. Sorry, this is df_diff. That's the name of our data frame, dot tail. When I put the 10 in there, it'll show the last 10. And so, here's 12.1. If you go back 7 days, if we count this one, 1, 2, 3, 4, 5, 6, 7, we get 559, right? So my understanding is, oh wait, I'm sorry. See, this has to do with the renaming. We didn't rename it something different. This is giving us the sum. What I wanted to check was the previous total, just to show you that it's working as it should. But I think we can, let's just assume for now that this does work properly. Basically what I'm saying is that if you have like 8 more with the case of 60, that you presumably have something like 52, 7 days ago. All right. So this looks pretty good except for one thing. I don't want to show every day. I want to show every 7 days. right? Because then it's like, well, I mean, it's advantageous to doing it like this, I guess. But in effect, it's no different than showing every day because you're counting every day, right? So what I want to do is actually show every 7 days because I think it's going to make for a cleaner graph. Okay, so here's a roundabout way of doing that. So we can do some indexing, all right? I like, so these comments I like to put in here so you know what we did. So you could say sum every 7 days. By row, okay? All right, and so now what I want to do is, there's a catch here. I want to start with the most recent, right? I want to know how we're doing today, not yesterday. So I'm going to start with this one, and then I'm going to go back 7 days. So here's one way to do it, okay? Please put in the comments if you know a better way. You can simply, so again, we're going to reassign it. And we're going to reassign it as that by index location. So I want to start at the back. So I want to start at -7. Okay. Now when you start at the back, this is kind of interesting. Oh, I just realized like maybe another way to do it. Sometimes you just experiment and try things. I know what this is going to do. Okay, but what I want to see is what is this going to do? Maybe that's what I wanted. So negative, by the way, means -7. It means you're starting 7 from the back. I just want to see this, okay? Little experimentation here. Sometimes with code, you just want to experiment. Okay, that's, yeah, okay, no. Okay, so what you may wonder, why am I doing the experimentation? I will show you because we have to do one more thing after this. Right, so df diff. So basically I'm indexing it, counting from the back by 7s, right? And I'll show you what that looks like. This is kind of fun. You ready? All right. It's starting, look what's happening. These are the last 5 rows. It reversed everything, okay? So that's not what I actually want to do because I want to graph it sequentially in order. So in order to reverse it again, okay, one more step here. What we did here is we selected 7 rows from the back. And now we're going to reverse it, okay? This should be the last step. So we're going to reverse the data frame. So this is kind of a cool little trick, right? That if I just copy this, okay, and copy what you just did. If I'm ever going too fast, you can always pause the video. And then just do -1. And so that should properly reverse it. Let's check. That's what I want. Look at that. This shows you, it was a little roundabout, but it does in fact show you the total number of new cases in the previous 7 days. And you can simply look at this and actually get very valuable information, right? Now, there is the issue of that last day has not been reported. So that's a little bit of a bummer. But look at the trend. This is good. Like it's going down in the month of November on 7-day counts. Okay, it's actually great. Now again, we have this new variety that's just come about. So maybe there's going to be an uptick in the subsequent 7 days. But this is like a really cool way of monitoring it. Okay, so that is step 1. It's transforming the data frame to potentially get it to do what you want. What we're going to go with next is a complete step 2. So for step 2, I'm going to make the graph and I'm going to do it of the previous 7 days. And I'm going to take population into account because these are different counties. And, I just think I mean, you could do it really either way, honestly, because it's valid to just have like the total number, right? But percentage is I don't know, it's just an even way if you want to do comparisons. And I think with some of the graphs we've done, it's kind of cool to compare it, right? Because this information can be valuable, which is like, oh, like how are different states doing, different countries, and using a population comparison will allow us to do that. And we do have a good amount of that code underneath because this is a copied notebook. Okay, so let us move forward into the second part of this, which is now going to be looking at, here's Contra Costa, by the way, for comparison. Also going down, but not as, like a little uptick. Not as significantly as Alameda. I'm just looking at the ones I was focused on before. LA nicely going down. It was up a little bit here, but trending down overall. So basically, this is November data primarily that we're looking at. I just wanted to get to San Francisco. And again, also that little uptick, but then down overall. So it's looking good overall. This is everything, right? And what it'd be kind of interesting to do the comparisons. Okay, so first of all, this could be an advantage, by the way, of doing it actually, because we do have it labeled differently. This is like every county. It's not taking population into account. So I don't know that we need to do that again. I mean, you could if you just want to get a quick kind of like how different is it going to look if we're only taking 7 days into account instead of everything. And it's also sometimes it's nice to have. I'll go ahead and run it. Sometimes it's nice to have a baseline graph. Now let's do df_diff though, the new one. Okay. And you can see like it looks totally differently and totally different. And the reason why, of course, is because we're looking at the difference. And you may have seen graphs like this online instead of the sum, right? Just like a continuous thing going up. So the idea of a flattening of a curve is you see it down here in between where it's actually kind of towards zero. And you even see, look, it looks like you can go under zero, right? Because if you, like the number of cases reported goes down, it's negative. So that's right. We're at the game of like leveling the curve of hopefully one day we can be in the side of this where we're underneath the zero, right? So that's cool. You see how it looks differently. And furthermore, note that this is not an everyday average, but it's every 7-day average. So I think it's a little more, I don't know, clear. Now these are all the columns. I'm not going to, you have them there if you want them, okay? I'm going to delete this out. And, I encourage you to do your own states, do your own counties for this. You could even do it by like states. I think I may do that actually, some state comparisons, because I think that can be a little more interesting. Especially for those of you like me, right? I mean, considering traveling maybe to a different state over the holidays, and you want to know like, well, how is that state doing? And it's true that you can find these types of graphs online, but it's also nice to do them updated on your own. And let's go through the process now of cleaning it up. Okay, so I'm going to keep this. These are my counties, my populations. You should have data there from your own. Don't need this. So what this was an original sketch, including population. And I've been using df Cali throughout. So to go back to it, which I think I'm going to go ahead and do for the ease of not having to copy and paste too much code, I can reassign df Cali to what I've changed it to, this df_diff dot copy. Okay, so you copy a data frame. Okay, so when I do that now, I'm saying, hey, you know what? I'm okay with where I'm at. I'm just going to forget about df Cali now. I'm going to reassign it to my new data frame, which is just looking at the differences. So I reassign df Cali. Well, it's really your whatever 2. I was going to flip it. And that way, it's the point of that is just so, hey, the code that we use was df_calc a lot, and so now when I do it, it's going to be the difference, not the difference data frame, not the original. So you can look at this one, right? Percentage of COVID cases since inception. And I could even change this to percentage of COVID cases. Maybe that's good to have. Is it per 7 days? Was that going to work? It should, because basically we're just dividing by the population, right? So instead of like, right, what's the difference? Here, this was a sum total, right? We got, like, we can look at it. Well, we have percentages. The percentages are 12, so it's like for Los Angeles here. So it was divided out. And now it's going to be not the cumulative sum, like, oh, in sum, 12% of people in total have had it. That's a valuable number, okay? It really is. But now I can say, well, this is the percentage actually who have gotten it in the last 7 days, right? Percentage of COVID cases per 7 days. Okay, so it should be less because it's not cumulative. And what this does, recall this was important, is that this gave us kind of the last 30 days. But now we're doing it every 7 days. So in effect, you probably want to change this to like, I don't know. How many like maybe try 10. I'm honestly not sure what we need there. We just go back and fix it. Okay, let's try to run it and see what we get. Okay, you can see we could probably do more of these. Very interesting, right? So we have Los Angeles, higher as expected. And look over here, it gets kind of like tricky to analyze, I think. So we're gonna look at this. Right, this is in sum since the beginning, percentage of COVID cases per 7 days, right? And it's releasing like over 7 days, like you're seeing like maybe you get like 1% of the population is picking it up at a peak. Usually it's closer to like, less than 0.5%. And you can also see some interesting things going here where you actually have a little spike in Contra Costa, kind of a leveling out, you could say. Okay, so this looks good overall. But I want to look at, again, I'm more interested in how is it doing like today. By the way, just to give you a sense of this X ticks, if I move this up a little and just do it again, let's see. Now I'm gonna go in the other direction. Sometimes you just try something. I want more labels. So more like every 5, put a label in. That looks good, right? Because now we're seeing it closer to like once a month. Now these aren't monthly counts. These are basically weekly counts, right? Okay, so down on the code, she'll last 30 days. Now, instead of showing the last 30 days, how about let's pick like something like the last 4 weeks or maybe 5 weeks. You could even do 10 weeks, right? Like if you're looking at longer terms, let's just go with 8. You could pick any number. So that's just going to be 8 entries, right? We call this df_calc 30 because it's the last, we're doing 7-day intervals. So I'll call it df_calc 8. And it should just show me the previous 8. By the way, if you can check, you don't need the dot head. Dot head shows the first 5. df_calc 8 will show the whole thing. And there we have it. There are the counts from the last 8 weeks. Okay. So now I can do it. Now, okay, these are some of the issues you can run into when you have a previous notebook. It's easier to do, but I actually have to divide by the population each time. Okay, so what we're going to do a little bit more on this. See how I have this like the, wow, I've got to do this each time. Actually, I think I'm going to do it here. Okay, I'm going to turn this into a function because I don't want to keep writing this out. Okay. Well, what the heck? Let's just go with, I don't want to, I'm more concerned. Now that I see how LA is, I think, yeah, I didn't use it here. I just used Contra Costa and San Francisco. Those are the closest counties to me. That's a 1 and a 3, it looks like. So all I'm doing is to prepare this next one, I want to continue with dividing by the population. And from here, I should be able to build out a function for these three. Okay? So I know there's a lot of code, but just bear with me. I'm not doing df cali 30, I'm looking at the last 8 rows. And what we're going to do next is write a function to take care of it all. And then it'll be much smoother. So you don't want to deal with copying and pasting. You just want to say, hey, I want a new graph. Let me put it out there. And I think I'll also do plt.figure, fig size equals, do something like, I don't know, 10 by 6, and then see how it goes. That's row numbers for rows by columns. Invalid syntax, I added something new. Forgot the division. Try it again. Look at that. That I think is actually, I think that's like beautiful mathematically. Okay, I just really like it. Why? Because it's just meaningful. Like, look at it. It's telling us, and it's exactly showing. I should put a title in here. Let's give it a good title to say what it's showing. Okay, what this is. Oh, gotta get all the way to the end. Try it like that. Get a space in there. plt.title. Okay, what is this? This is the percentage of COVID. How about new? Percentage of new COVID. Percentage of COVID cases per week. And again, the reason why I put it in California counties is because not everybody knows what these are. So they might think they're cities if they see San Francisco in there. We can say Bay Area counties, actually, it's more specific. All right, so press Shift Enter. Look at that. It's a little, my screen's blown up a little. So if I do like Command minus, it goes down to 175%. We can see it all. So let's just look at this graph for a minute. Okay, first of all, we see downward trends overall. Looks like San Francisco did have a big spike here, the beginning of November. And I don't know why, but it's there. And interestingly, Contra Costa steadily trended downward. And Alameda has been lately, so that's a good sign. And actually has the lowest reporting from the last 7 days. Although again, the 7th day thing is a little bit of an issue with this last day. So we could potentially, I would advise considering going back and removing the most recent row of your data to, get it a little more accurate if they're not reporting it. So but it tells us a lot, right? It gives us these numbers on the left. The left is meaningful, right? So I did multiply it by 100, so these are actual percentages, right? 0.07%. It's not 7%, right? It's 0.07%. Okay. And you can always change these two. You can say because percents are out of 100, and you can say it's out of 1,000, right? Because the numbers can be more confusing to read. Now you're going to need two here, right? So that's out of 1,000. So if I change it to 10,000, right? Now instead of percentage, it's number of COVID cases per 10,000 people per week. Okay, let's see if that does what I expect it to. Yeah, so I only do that because I know people have issues with reading decimals, but they know this is 7, and that means 7 out of 10,000. Okay, so that tells us how well we're doing, right? And it's per week, you all, which is also nice because it's in effect 1 person per 10,000 per day is being reported. And this is where, right, when you have control of the data, you can get it to say what you want it to say. Just takes a little kind of finessing with it all. So last thing to do, we'll call this part 3. I like what I have here. I'm going to turn it into a function, okay? And basically what the function will do is it will allow me to kind of adjust a couple of things and produce the graphs. Now, to keep it relatively simple, I'll just stick with these 3 counties. Okay, so here's one idea. But actually, well, we'll put this in first. I'm going to copy in the code I just made. Okay. So that's my graph. But then I also want to be able to mess around with this, right? This was the last 8 weeks. Okay. So I want to combine these two into a function, right? Okay, so how do I do that? So here we go. Bear with me. Okay, df, last thing. I don't know, you can call it whatever you want. COVID graph. There's some different ones. Let's start with Bay Area. Bay Area COVID. What about Bay Area counties? COVID. Okay, and so these are 7-day periods already. Okay, so I'm going to say number of weeks, and like so my default I picked was 8, but I want to be able to change that. Okay, and what else do I want to change? Is that it? You know, if you're going to keep the same counties, that might be it. Okay, sometimes when I start writing, I realize there's something else. Okay, so how do we do that? Well, first thing you want to do when you're writing a function, you want to shift everything inward. So you highlight it all, press tab, and see it goes in. Okay, that means it's a part of this function. And this is the syntax for writing a function. You write def, that starts a function, and then you name it something like Bay Area County's COVID. You can name it anything you want, actually. But what's important is this is a parameter I want to be able to change. Okay? And so it's called number of weeks, and so what I do is I just change it to number of weeks. Now, what I call it doesn't really matter. I mean, to call it df cali 8 is a little bit like, you know, let's call it, say, last in weeks. Maybe it doesn't really matter. Let's call it df cali 2 for like the second df cali. And I'll keep this kind of like COVID cases per 10,000 people per week. Gosh, is it really that simple? Let's try it. Okay. Oh, I forgot something critical I mentioned I would show everyone, which is I want to be able to export it too. So that's after the legend. PLT dot, oh my gosh, save fig. I'm just forgetting it. And this, typically, like I like to save it as, well, yeah, see, I want it to be save it differently for each function. The only different thing here is the number of weeks. Okay, so I'm going to show you a way to do that. You can do it with an F string. Okay, this is what you do. If you put that F there, that's an F string. Okay, it doesn't change anything. But the nice thing then is, oh man, where do I want to include it? I like the per week. Shoot. Basically, I don't know. You could just put it in here maybe. So you can put it in brackets and you can say something like, yeah, I'm gonna shorten this a little, say COVID cases per 10,000 people per week. And in here I can say basically, so when I put in num weeks in brackets, okay, that's the advantage of an F string. It's just gonna convert it to like if I use 8 to 8. So after that, I want to say then weeks. So that should translate to 8 weeks. Now to save the figure, what I want to do here, you see this title? This is my title, it's a lot. I'm going to call it out separately because I use it in 2 places, okay? So I call it just with the name title. There it is. and I put it inside of the title, okay, this plt.title. If that confuses you, you can just call it name if you want. So name, and then here you save it as the name, and then set the DPI equal to. We had an issue with this, with the saving. Let's see. I don't think we have it here. Okay, we had an issue with it because of the dates. If you use like the backslashes, I don't like that. I feel like the DPI dots per inch, I can't remember, something like 225 should be good. Okay, so now I'm going to try to run the function. Invalid syntax. Oh, I left off something. Invalid syntax means like the Python code is wrong. You didn't write it correctly. It needs a colon at the end. Okay, and so after that, that's all of the function. By the way, other errors you could see. If you have like something like that, that's not going to be in the function. There'll be nothing inside it. And so everything's got to be tabbed. If you leave something off, like a quotation mark, what they should do is say invalid syntax and highlight it for you. Like, watch. Let's see if that's what happens. Okay, so I'll try this again. Change something. See how it's underlined? It says EOL while scanning string. Literal. But look, go to the underlining. They have a little arrow there, and you might say, oh, you can compare your code to mine and see, well, I have a quote there and you don't. So put a quote in there. Okay. All right, let's try that. Okay, that worked. Now, here's the big test. Can we run it? And how about this? We already looked at the last 8 weeks. And by the way, these are supposed to be like dots per. They're supposed to be, I think, inches actually when you export it. So if I want to do like an 8 by 11, I could do like 11 and 8. Let's try that. Okay, I'm going to run that again. And how about over the last 12 weeks? So that's like the last 3 months. How have we been doing? You don't need the colon. And let's see, it doesn't work. Beautiful. The dates are a little crowded at the end. Oh, look at that too. Like that's such a good sign overall. Look at that. All right. Instead of saying 12 weeks too, see what I do is I tend to graph and then I like make an adjustment. I'm gonna say like last 12 weeks, right? Because it's the most recent. And the other thing is, you might wonder about the save fig piece. That looks pretty good, I think. I want to shift the dates though. Do you remember how we did that? I have to check actually. Here it is. See how they're rotated? plt.x ticks rotate. I think that just looks better. 45. That way it doesn't crowd. You got to put these things in the right place too sometimes. Looks like it is after the plot, so that's okay. Okay, so I come back to my definition of the function and just put it in there wherever. Try it again. Now it's interesting, when I do this again, it's going to overwrite because it's the same. I'm not changing the number of weeks. Yeah, it just looks cleaner, doesn't it? Look at that. Outstanding. Okay, so now, and the last thing I want to do is show you. Oh, it looks like it did rewrite it. That's where it is, okay? When it saves it, so it's in this file folder. So if you click on that, that's where you see it. This gives you a much nicer output. So if you want to download it to your machine, okay, you can see mine downloaded here. And so if I click on it to open it, mine went elsewhere. I'll drag it over here. It looks really nice. I'm very satisfied with this. It's informative, it's clear, it's clean, you know. Looks good. You know, you can adjust things accordingly. Before signing off, I'll just have quickly a little fun with it. Why not? Like, this is the beauty of the functions, right? You can, in fact, now change these to whatever number of weeks you want, right? So now what I'm going to do is instead of the last 12 weeks, I want to go back further, say I want to go back to, I don't know, try the last 20 weeks. Why not? Now that might crowd the dates, so that's why it can also be advantageous to experiment. Okay, they still show. Well, look at that spike. There is a where is that? Early September. Big spike. I remember hearing, by the way, about an outbreak at the beginning of the school year with Contra Costa. And that's what we're seeing that here in the data. But that's kind of like an outlier, really. You know, the rest of it's kind of, there's a little peak and then a steady downward trend. And nicely, the date's preserved. And then let me check now a smaller one. Just check the last month, the last 4 weeks. Okay, it doesn't look as spectacular because it's only got 4 markers, but you know, if you've been wondering like how have we been doing the last 4 weeks, there you have it. And furthermore, this gives you a pretty clear look at the last week, right? I did say, well, look, there is that one row. It's a little bit of a concern. So, you know, you could go back and change it. And just let me just show you how to do that, okay? It can be cool too to end it actually at the end of November. So I go all the way back up. And by the way, all those graphs should be here because it's outputting each time, okay? I go all the way back up and I want to find, not there, I want to go like to the, kind of to the top, okay? And if I go to the top, I will see, before we did all the differences and all that stuff, just the regular kind of like counts. I mean, like here, you could get rid of the last column even, okay? You could do it in a lot of places. You could chop out, let's just go to where's the most. Like if you're gonna exclude the most recent row, right, it's the last column. So what I can do here is I'll put this code in and say it's optional. Delete last column. Okay, and when I do that, I can do, what are we calling it here? It's still df Cali. Okay, I haven't done the differences yet. So it's df Cali. I'll just rename it by, I got to name it the same thing, go df Cali dot ilock. So here we go. All rows, okay, all columns up to and excluding the last one. Okay, that's syntax for that. That means stop on the last one. And as always, I do like to double check these things. So you can see it's 12.1. So I'm saying my hope is that 12.1 will now disappear when I check it. Okay, so do that. Scroll all the way over. Oh, I know what the issue is. Yeah, the issue is we rename df Cali. So not to be concerned here, just what you do, click on this, so go to runtime, run before. So you're restarting the labeling process when you do that, okay? You're only running the cells before. Now df Cali is what it is above. This is why it's worth checking too, right? And you can see there is no 12.1. So now, go all the way down to my graphs, okay? I'll go all the way down to the last one I created. This one right here. I'm going to get rid of, this will be a nice clean notebook here. I'm going to get rid of everything else underneath it because I don't need it. It's tempting for me sometimes to be like, oh, what's underneath it? Like, I'm sure there's great, cool stuff we could do. But now I can just go to runtime. You ready? Just do restart and run all. So you always want to do this before you're submitting a notebook, by the way, because your code should run top to bottom. And so now when it runs top to bottom, it should end on 11:30, and we may see a difference because, you know, the data was not properly updated. And what we see is frankly not much of a difference, right? We see that it is still going down despite the apparent spike, remember that, on the day after Thanksgiving. So in conclusion, I will say this. A lot of statistics is about analyzing data. I want to say like it's not quite common sense. It's beyond that. But you want to look at things carefully. And when you see unusual occurrences, you want to like do something about it. So if I go back up to the top, what were the unusual occurrences that I saw? It was basically here, right? Actually, no, it was after. See, you can't really tell much here. You can tell, oh, hey, maybe these weren't updated. But it was actually here when we did the difference columns. And it was like, okay, 464 and then four zeros. That doesn't add up, right? And so what we did is two things. Like we actually no, we already had done the one, which is hey, let's look at the difference, and the second was to look at the 7 day period. That's basically what this was all about. So I hope that was helpful. I know it's a lot of code for some of you, and my hope is that there's something that you can gain just from little modifications of the code to really make this work for you, whether it's different states, different countries, different counties. I encourage you to play around with it and have some fun. Thanks.